Jai Hind everyone. Myself Dr. Aditya Pratap Singh, Associate Professor in IT Department of Ajay Kumar Garg Engineering College, Ghaziabad. Today we are going to discuss the topic Union in C. In the last video lecture we studied the structure and the remaining topic union was left. So, we will continue with that. First of all, I would like to remind you that what was the structure. Structure was a user defined data type which we can create in C programming language, and it was slightly different from arrays. Array was a collection of data where we store homogeneous type of data. That means we are collecting or we are having elements of the similar data type, whereas in case of structure we are allowed to have a bunch of heterogeneous data type. That means we are creating a bundle where multiple type of data members may be available. That data members can be integer type, float type, character type, or even structure type itself. So, such type of structure which we have already covered in the previous lecture, and the usefulness of these structure or union data type is different from arrays. In case of structure, what we do, we generally create a collection like for a person can have name, that will be a character array. Person can have a mobile number, that may be a long type, and person can have a address, that will again be a character array. Person can have a date of birth, that can again be a character array. Person can have age, and that can be a integer value. So, we can make a bunch of all these members and bundled it as a person template, and then we can create variables for that person 1, person 2, person 3. So, such kind of thing we were doing in structures. So, now let us start with the union. So, union is a special data type available in C that allows to store different data types in the same memory location. Here is the key point, that same memory location. In structures we studied that the overall size of the data structure or the variable of a structure type will be addition of requirement of all the data members. But here in union, what is the difference? The difference is that everything is being stored in the same memory location. That means every member is sharing that same memory location. So, you can define a union with different type of members, like I have given here an example, like we are having a union for car. That car may be having some name and its price. So, we can define a union with different or heterogeneous members, but only one member can contain a value at a given time. That is the key point. Means it is happening because the memory is shared, and this shared memory will allow only one variable to be in force. So, the last variable which is assigned the value will be the valid one. The previous members which were assigned values, their values will be overwritten or distorted, because the next value which is given to a particular member will overlap the value held by previous members. And the unions provide basically an efficient way of using the same memory location for different purpose. Like if I want to have a data type which may have different kind of values, but at a time only one value will be useful. For example, if I want to have a data type for my internet connection, okay, we take a real world example. Like I want to take internet connection, and I am creating a program that which connection is working now. So, I will create a data structure for internet connection, and I'll having LAN connection, Wi-Fi connection. So at a time only one connection will be valid. So same kind of philosophy here in the union, that at a time only one member will be valid. So here like the keyword for declaring a union is union. Union is the keyword for declaring a union type, and the name or the identifier for that union, and these are the members for this car type union, the name and the price, and these are the variables of type car type variable C1, C2 and pointer C3. So we have created three variables along with the declaration for a type car. Okay, so unions are quite similar to the structure in C in terms of declaration syntax, in terms of accessing syntax, in terms of, so the usage may be different, but the creation is almost similar, as well as the accessing pattern or accessing mechanism is similar. So union is also a derived type structure, and it can be defined in the same manner as structures. Just the keyword used in definition of union is union, and in structure that keyword is struct. So one thing we need to emphasize, that when you store a value in the union, it overrides the previous value, because the same memory location is going to be used. All members of a union share the same memory. This is the key point for union and the key difference from the structure. So now let us learn how to access the members of union. The union members can be accessed in the same manner as we were doing in structure, like with the help of a dot operator. A dot operator is used, the variable name. So what is a variable name? Variable name dot member name. So this dot operator is used to access the member of union. Like in this example, like we are having here C1 dot price. Like if you want to access the price of a union through a pointer variable, so through pointer variable it will be a arrow operator. So C3 is a pointer type, and so we need to access the members using C3, that will be through a arrow type. So what we understood, that point is used for normal variable, and arrow is used for pointer variable. This is for normal member. Member access. So pointer variable can also be used, normal variable can also be used, but the accessing mechanism will be little bit different. So now let us understand what is the difference between union and structure. The memory allocation of each member of a structure has a separate memory location. In case of structure, every member has independent access, like you can understand in real world, like in a house, every member has its own room. So nobody needs to interfere in others' space. So everybody is having their own room. So that is the philosophy in structure. But in case of union, the memory allocation is in the same memory. All the members are sharing that space. So like if we are having outlet and office chair is only one, So at a time only one owner will be sitting on that chair. So the same thing is here. At a time only one variable will be valid or in force, which is given value at the end. The size of structure is the sum of the size of all its members, because every member needs independent memory storage. So the size will be the combined, but in case of union, the size is given only for the largest member. The size will be equivalent to the largest member, and rest which are requiring less memory space, they can adjust in that size. So everybody will be adjusted in the same memory location at a time one only. In structure, all members can be accessed independently. All members can be accessed independently because they are having their own memory locations. While in case of union, only one member can be accessed. Only one member will be in force, or only one member will be available, because the memory is same. Structures are used when you have a set of related variables that you need to group together and access independently. But whereas the unions will be used when you need to store the different types, when you need to different type and is in a single variable. Union will be used when you want to have that there may be possibility of having different types, but only one will be valid at a time. So you can access one of them at a time. Like I have told you that I want to have Wi-Fi connection or LAN connection. If I am having both, only one will be valid at a time. I am accessing internet through one. If one is LAN is down, then the system will switch to Wi-Fi. So this is how, means at a time one we are having only one connection. So again, to better understand the difference between union and structure, here the programming part or the syntax part for a union is quite similar. So first let's try to understand how unions are created. So like here in this example, we have created a union named as job. If I would be creating a structure, corresponding structure or similar structure, what I can do, I hope you remind that keyword for creating a structure is struct. So I am having same this one. So yes, struct job one. So we are having one union and one structure. So union we have created job, and structure we have created job one, having same memory, having same kind of members. So union is also having a character name of size 32, a float salary, and the worker number of type integer. So let's understood that integer is 4 bytes in our compiler. Some compilers have 2 bytes integer. So I am talking about a compiler or where I have created this program, that compiler was of 4 bytes required for integer. So here total requirement for a structure variable, we have created a structure variable s and we have created a union variable u, and we want to print the size of u and size of s. So now you will better understand the difference between the pattern of memory allocation for union variables and for structure variables. So what is happening here? Let's try to understand. The size of union is 32. What we have done? We have 32 byte long character variable, character member. We are having a salary member of type float and integer type worker number member. But the size which we have got is 32 only. So, if you see that the size of a union is equal to the size of its largest member. So, we are only giving or reserving the memory area equivalent to the largest member only. So, here the size of u will be 32 given, because float requires 4 byte, int requires 4 byte, and they can be adjusted in these 32 bytes allotted to the union variable. So, there is no issue. But in case of structure, every member has independent memory requirement. So, everybody will be given independent memory. So, 32 plus 4 plus 4, that means 32 plus 8, 40 bytes are required for a structure variable. So, I hope it is very clear to you that what kind of requirement you are having when you are creating a union and when you are creating a structure. The usage of union depends on the requirement where you need to access or you need to use the memory very efficiently in a manner like all the members of union are accessing or sharing the same memory location. So, let us more understand this. So, the difference in memory allocation between the union and structure, as in the previous example, the amount of memory required to store a structure variable is the sum of memory size of all the members, that is 32 bytes for name. It was a character array of size 32. So, 1 byte for character into 32 characters. So, that becomes 32 bytes. 4 bytes for salary. Salary was a float type. So, float requires 4 bytes. Worker number was of integer type. So, it requires 4 byte again. So, 32 plus 4 plus 4, that is memory allocation structure will require 40 bytes. All are added, that is the requirement. But the memory required to store a union variable, where the memory required for largest element of a union member. So, that will be only 32 bytes. So, you know that all members of structure can be accessed, all member of structure can be accessed at any time in the program, because they are stored in the independent memory locations. Whereas, in case of union, the other members, or only one member will be valid at a time, because every member is, each member is sharing the same memory location. So, this is the another graphic for better understanding the memory requirement for structure and union type. So, this is like roll number, gender and marks. So, marks is of type integer, gender is of type character, and roll number is of type here it is of type integer of 2 bytes. Marks is float of 4 bytes. So, 4 plus 1 plus 2, that is having, we are having 7 bytes long variable, whereas in case of union the largest one is 4 bytes. So, we will be having this will span up to 4 bytes only, because 4 bytes are the is the largest requirement. So, memory equivalent to the largest requirement will be allotted for a union variable. So, that is basically happening in case of structure and union. Now, let us understand on that what how it is happening. Only one member of union can be accessed at a time. So, here in this example we have created one union job, name, salary and worker number, the same example. We have created a variable u and we used this, enter a name, and we store the name in u dot name, address of u dot name, and we have entered the salary, u dot salary, and now we displaying the name and salary. So what is what actually name is having 32 bytes, salary is having 4 bytes float. So 4 bytes requirement and name. So what we have allotted, we allotted the name first and then we allotted the salary. So what is happening here? Name is Asutosh, salary is 123.23, but what happens to the output? The name part is not consistent, or name part is distorted, because it requires all 32 bytes to be read. But whereas salary is perfectly all right, because salary is allotted at last. So these bytes are overwritten on the name Ashutosh. So that has been disturbed. So that because you may get different garbage value of the name, because that name will be distorted. Those 32 bytes is having 4 bytes are having data for salary. So I hope you are clear about this, that why it is happening. Let's understand more. I am having a union A, one integer and one character array of size 2. So I am having a union variable u, and u dot ch 0 is 3, u dot ch 1 is 1. So what is happening? We are having character of 2. So we have stored 3 and 1. So what is this? These are basically integers which we stored in type is char. So we have stored integers in the space of character. Characters are internally treated as integers. I have already discussed this in the previous lecture, that characters are stored in the form of integer into the memory, because most of the time their ASCII value or the ASCII code corresponding to a particular character is stored in the memory. So here we have displayed %d, 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 UCH0, UCH1 and U dot I. We have not allotted, you can see that not we have not given, we have not given any value, not assign value to integer part, integer I. We have not assigned any value to integer I. So but we are printing ch0, ch1, ch0 and uch1, first in integer form, second in character format. So what will happen? The output will be 3 and 1 if we are printing as integer, and 251 if we are printing like UCH0 when %d, then it's okay. But when we are printing as u dot I, so it is being printed as 259. And in the second, we have assigned characters to 0 and 1 location. So character A will be 97, that is the ASCII code, and B will be the 98, that is also ASCII code. But if we will print them as using %c, then they will be printed as characters, no issue. But I think there should be a confusion about why this value is coming, why this 259 value is coming. So let's understand why this 259 is coming, because the system will allocate 2 bytes for the union. Here integer is of size 2 byte. So, the statement UCH0 is equal to 3 and UCH equal to 2, it will store data in the memory. So, first byte will become this, second byte will become this is value for 3 and this is the value for 1. So, this will be the combined value, and if we combine it, then it becomes 259, because 1 will be here and this 1 will be treated as 256 in binary, and because they are combined, now they becomes 4 bytes. So, its location changes, and as per its location its value will be changing. So, it becomes 253, 256 and 3, that becomes 259. So, I hope I am able to make you understand the concept of memory allocation for union kind of variables. So, it is generally useful when we are performing embedded programming in some situations where direct access to hardware or memory is needed, and like for example, changing the size of cursor at a time, only one kind of cursor we are using. So, different values, different type of values may be required, but only one will be valid at a time. So, sharing an area to save storage is uses, and structures are more used in programming, and unions are used only when particular type of requirement where we can have multiple variable types, but at a time only one is required. In such kind of situation we use union. So, that is all about union. Thank you very much. I hope you enjoyed the lecture. Thank you.